Every population in Europe eventually surrendered, every bloodline mixed, every language, sooner or later, bent under the weight of whoever conquered next. The Romans came, and Latin rewrote half the continent. The steppe herders came and rewrote the other half, replacing nearly every paternal lineage they encountered within a few hundred years. Empires rose, fell, and left their genetic fingerprints on everyone who survived them. Everyone, it turns out, except one small population pressed into a corner of mountains between what is now Spain and France, a people who looked at 10,000 years of that relentless overriding and simply didn't absorb it. For decades, nobody could explain why. Now, ancient DNA finally can. And the answer is stranger than any of the old theories ever guessed. The people in question call their homeland Euskal Herria. The rest of the world calls it the Basque country, a rugged stretch of green, wind-battered terrain along the western Pyrenees. For generations, linguists, anthropologists, and historians have stood at its edge with the same quiet frustration. Nobody could pin down where these people actually came from, and their language offered no clues because it belonged to nothing. Nearly every language spoken in Europe today traces back to one of a handful of family trees. French, Spanish, Italian, and Portuguese all descend from Latin. English, German, and Danish share a Proto-Germanic root. Russian, Polish, and Czech trace to Proto-Slavic. Even Persian and Hindi, spoken thousands of miles away, share a distant common ancestor with nearly every European tongue, in what linguists call the Indo-European family, one vast interconnected linguistic web stretching from Iceland to northern India. And then there's Euskara, the Basque language. It fits into none of it. It predates the arrival of Latin, predates the spread of Indo-European speech across the continent, and predates the very nations it exists inside today. Linguists have never been able to convincingly connect it to any known parent language, Indo-European or otherwise. Theories multiplied for over a century. A Caucasian connection, North African roots, a surviving fragment of the original Stone Age tongue of Europe. Each theory had believers. Each had holes nobody could patch. None of them could be proven because the tools to look deep enough into the past simply didn't exist yet. The tool that finally cracked the mystery wasn't a new excavation or a rediscovered manuscript. It was ancient DNA, genetic material extracted from human remains thousands of years old, sequenced with computing power previous generations of researchers could only have dreamed of. And when the results came back, published in the peer-reviewed journal Science, they didn't just answer the mystery. They dismantled almost everything the academic world thought it understood about who the Basques actually are. The genomic evidence points to nearly 700,000 modern Basques descending from Neolithic farmers who mixed with the local hunter-gatherer populations already living in Iberia, and then, at some point after that mixing, became genetically isolated from the rest of Europe for thousands of years. That single sentence contains a genuinely difficult idea to process. A population that stayed isolated, in a meaningful biological sense, for millennia, while sitting directly in the path of some of the largest population movements in European history. To understand how extraordinary that isolation really is, you need to understand the scale of what was happening to everyone around them. Around 5,000 years ago, a massive migration began rolling westward out of the Eurasian steppe, the Yamnaya, a nomadic horse-riding, wagon-building people originating in the region of modern Ukraine and southern Russia. This wasn't a gradual trickle of contact, it was a demographic transformation. Genetic evidence shows that by around 4,500 BC, descendants of these steppe populations had arrived on the Iberian Peninsula, and within roughly 400 years, the paternal lineages already present there had been almost completely replaced. Close to 100% of Y chromosome lineages in Iberia were overwritten by newcomer ancestry in that window. an almost total replacement of the male genetic line for reasons that remain debated, but notably without clear archaeological evidence of large-scale warfare, mass graves, or violent conquest to explain it. Sit with that for a moment. Nearly the entire paternal genetic history of an ancient population erased and overwritten within a handful of centuries. And it happened not just in Iberia, but in wave after wave across most of the European continent. Later, beginning at least as early as the Roman period, further gene flow arrived from North Africa and the Eastern Mediterranean, adding still more layers on top of what the steppe migration had already reshaped. Each new arrival wrote over part of what came before. That is, more or less, the story of the entire European genetic landscape, except in one place. What the ancient DNA research shows is that present-day Basques look genetically like a preserved snapshot of an Iron Age Iberian population, roughly 3,000 years old, largely without the later admixture events that reshaped every neighboring population. The Romans, who conquered Britain, absorbed Gaul, and controlled the entire Mediterranean coastline, left essentially no detectable genetic trace in the Basque genome. The Moors, who ruled most of the Iberian Peninsula for nearly 800 years, left the same negligible mark. Researchers examining the data found none of the North African genetic influence present in virtually every other Iberian population, and no meaningful Roman-era signal either. That's a genuinely strange thing to encounter as a historian. Rome built roads through Basque territory. Rome administered parts of Basque land directly. And yet Roman DNA barely registers in the population living there today, in a way it clearly does everywhere else the empire touched. How does a population survive the Roman Empire, the Visigothic invasions, the Islamic conquest of Iberia, the centuries of the Reconquista, and the entire medieval period, and come out the other side with a genome that still looks, in large part, like it did 3,000 years ago? According to the researchers behind this work, the answer isn't any single cause. It's a combination: geography, sustained cultural distinctiveness, and, critically, a language barrier that functioned almost like a biological wall. The genetic differentiation observed in Basque populations doesn't trace to some entirely separate external origin. It traces to genetic continuity since the Iron Age, reinforced by long periods of isolation and limited gene flow. Isolation the researchers explicitly link in part to the language barrier itself. This is the detail that tends to get underappreciated. When two populations come into sustained contact, genetic mixing usually follows the same pathways: trade, intermarriage, political alliance. And nearly all of those pathways depend on some form of shared communication, a common language, or at least enough of a bridge between two languages to make daily life together possible. Euskara offered no such bridge. It wasn't Latin-derived. It wasn't Germanic. It wasn't anything any incoming population had a linguistic foothold in. Its grammar operates on an ergative absolutive system, where the subject of an intransitive verb is treated grammatically the same as the object of a transitive verb, a structural feature that's rare in Europe but shows up scattered elsewhere in the world, from the Caucasus to parts of the Americas. For any outsider trying to integrate, the language itself was close to impenetrable, and that impenetrability appears to have functioned as a genuine barrier to the kind of intermarriage and mixing that reshaped every neighboring population. Here's where the newer research gets genuinely interesting, because it doesn't just confirm an old myth, it overturns it. For decades, the standard academic story held that the Basques were the direct unmixed descendants of Europe's original Paleolithic hunter-gatherers, untouched survivors of the Stone Age, a kind of living fossil that had somehow avoided the agricultural migrations sweeping in from the Middle East roughly 6,000 years ago. It was a clean, romantic narrative. It also turns out to be wrong, or at least badly incomplete. The genetic evidence instead shows that the Basques' closest ancestors were early Iberian farmers, descendants of that first wave of Neolithic agriculturalists who arrived from Anatolia and mixed with the Mesolithic hunter-gatherers already living on the peninsula. In other words, the Basques aren't untouched Stone Age survivors at all. They're the product of an early mixing event, just like most of the rest of Neolithic Europe. What makes them different isn't that they avoided mixing, it's what happened after. They became isolated from subsequent waves of migration, first the ones arriving from the east, later from the south, while continuing limited local mixing with existing populations already in the region. That's a more layered, more interesting story than either the old myth or its simple correction. The Basques aren't a pure, untouched relic. They're something closer to a population that mixed once, early, and then sealed itself off, a genetic time capsule, closed somewhere around the dawn of the Iron Age, and left largely undisturbed ever since, while the rest of the continent kept being rewritten around it. If the isolation story ended there, it would already be one of the more remarkable case studies in European population genetics. But there's a second entirely separate line of evidence that points to the exact same conclusion, and it's written directly into Basque blood chemistry. Basques carry the highest documented concentration of Rh-negative blood type anywhere in the world, commonly cited between 30 and 35% of the population, compared to roughly 15% across the general European population, and far below 1% in most East Asian and Sub-Saharan African populations. At the molecular level, Rh-negative status results from a complete or partial deletion of the Rhd gene, not a subtle variation, but the outright absence of a gene the overwhelming majority of humans carry. Researchers studying the Rh blood group system in Basque populations attribute this concentration to the same underlying cause as the broader genomic pattern, a long period of genetic isolation combined with a founder effect predating the arrival of Indo-European-speaking migrants into the region. In a small, sufficiently isolated population, traits that would ordinarily get diluted by continuous mixing with a larger surrounding gene pool instead become concentrated over generations, amplified rather than washed out. The Basques, cut off by geography and language from the wider gene flow reshaping the rest of Iberia, ended up locking in a blood chemistry profile essentially unmatched anywhere else on Earth. Basque populations also show an unusually high frequency of type O blood alongside of that elevated Rh-negative rate, a combined signature distinctive enough that geneticists can often flag likely Basque ancestry from blood typing data alone, with a reliability few other European populations can match. Layer the language back on top of the biology, and the full picture comes into focus. Before Indo-European speech spread across the continent, before Latin, before the Celtic and Germanic tongues reorganized how Europeans talked to each other, there was an entirely different linguistic landscape across the continent, one that has otherwise vanished almost completely, surviving today only in scattered place names, loanwords, and archaeological inference, except again in one place. Researchers studying the spread of Indo-European languages describe a plausible scenario in which those expanding language communities gradually absorbed the older languages they encountered everywhere else in Europe, while Euskara survived largely intact specifically because of the remote, defensible geography of the Pyrenees. That makes Basque, by a fairly reasonable argument, the closest living approximation available of what pre-Indo-European European speech actually sounded like, an audible fragment of a linguistic world that disappeared everywhere else on the continent between 3,000 and 5,000 years ago. The real question isn't just how the Basques survived, because plenty of mountain populations have tried to resist absorption over the centuries, and mostly failed eventually. The Caucasus, for instance, produced numerous genetically distinct peoples, but even most of those groups show significant evidence of historical mixing over time. The Basque case is different in both degree and kind. Geneticist Matthias Jakobsen, whose team worked on the ancient Basque genome research, told the BBC, "It's hard to speculate, but we've been working with Basque historians, and it's clear from the historical record that this area was very difficult to conquer." That's a fairly restrained scientific statement, but it maps cleanly onto the actual historical record. Rome administered parts of Basque territory, but never fully subjugated Basque culture the way it subjugated Gaul or Britain. The Visigoths swept through Iberia and left the Basque genetic signature essentially untouched. The Umayyad Caliphate pushed north through Spain with remarkable speed in the 8th century and stopped short of permanently absorbing the Basque highlands. The Franks pressed from the north, the Spanish kingdoms pressed from the west, and every one of these powers touched Basque territory without ever fully consuming it. There's a phrase sometimes used to describe the Basques that captures the strangeness of their historical position. Well, Europe's oldest nation that has never been a country, occupying a stretch of land marked on no maps except its own. A people without a state, and paradoxically, that statelessness may be part of what protected them. Without formal political absorption into a larger empire's administrative machinery, the usual mechanisms of gradual cultural erasure had less to work with. The most direct assault on Basque identity didn't come from Rome or the Caliphate. It came far more recently from Francisco Franco. During the Spanish Civil War and the dictatorship that followed, Franco's regime banned the Basque language outright, suspended Basque political and cultural rights, and, in one of the most infamous acts of the war, bombed the Basque town of Guernica, an attack that prompted Pablo Picasso to paint one of the 20th century's most recognized works of art in response. Franco understood something about language that gets underappreciated. It isn't just a communication tool. It's the architecture that a people's memory, relationships, and sense of self are organized inside of. Suppress it thoroughly enough, and you don't simply silence people. You begin to dissolve what makes them a distinct people at all. The ongoing persistence of Euskara has, at various points, been treated as a direct threat by centralizing governments in both Spain and France, resulting in real discrimination and, in some documented cases, direct suppression, including the forced closure of Basque language publications, which drew international criticism. What Franco's regime didn't fully reckon with, and what genetics has since confirmed with hard data, is that the Basques had already survived something considerably more total than a 20th century dictatorship. The complete genetic overriding of the entire continent around them, repeated across 3,000 years. Despite decades of active suppression, Euskara has experienced a substantial revival since the end of Franco's regime, used today in television, music, literature, and public education. The language outlasted the dictator, just as it had outlasted everyone who came before him. What the genetic and linguistic findings converge on is not incidental. The research explicitly supports genetic continuity among the Basque population since the Iron Age, with limited detectable influence from the Roman Empire or later North African migrations, a pattern that lines up closely with the archaeological and historical record, and one the researchers explicitly connect to the isolating effect of the language barrier itself. Geography, language, and cultural persistence didn't operate as three separate coincidences. They reinforced each other continuously across 3,000 years, producing something without a clear parallel elsewhere in European history, a living population whose genome still functions, in large part, as an actual photograph of what Iron Age Iberia looked like before Rome, before Islam, and before the medieval Christian kingdoms remade the peninsula in their own image. There's a broader implication buried in the Basque case that goes beyond one population's unusual history. In a modern world organized around nation-states, passports, and citizenship, it's easy to assume identity is fundamentally a political and cultural construction, shaped by the flag you're born under, the language your schools taught you, the history your textbooks handed you. The Basque case complicates that assumption. Under the right conditions, sustained geographic isolation, linguistic impenetrability, cultural tenacity, and enough historical luck to avoid full political absorption, identity can carry a genuinely biological dimension that persists through political upheaval. Most populations don't survive intact. Genomic comparisons show a significantly lower level of post-Iron Age admixture in the Basque population than in any neighboring Iberian group, not because the Basques were somehow untouched by history, but because, uniquely among their neighbors, the historical rewriting that reshaped everyone else around them largely stopped at their border. Today, Euskera holds co-official status alongside Spanish within the Basque country, and is also spoken across parts of Navarre and southwestern France. Roughly 1 million people speak it fluently today, including a substantial number of young learners and members of the Basque diaspora across Latin America, a genuine revival of a language that was, within living memory, actively suppressed under penalty of law, and came uncomfortably close to being pushed out of daily life entirely. The genetic findings don't diminish that revival. If anything, they deepen it. When a Basque child today learns Euskera, they're not simply picking up a second language for school. In a very real sense, they're participating in a continuity that traces back through the Iron Age, through the original Neolithic mixing of farmers and hunter-gatherers in prehistoric Iberia, connecting to a version of Europe that otherwise left no other living trace anywhere on the continent. The language and the genome aren't two separate stories here. They're two expressions of the same one. None of this is fully settled science, and the researchers working on it are the first to say so. 3 competing hypotheses about deep Basque origins have circulated for decades: a shared ancestry with Caucasus populations, a migration from North Africa several thousand years ago, or direct descent from Europe's original Paleolithic populations. The newer genomic evidence has complicated all 3 without cleanly resolving any of them. Elements of each appear to hold at least partial truth, layered on top of each other across a genuinely long and complicated history. What comes next is a push for higher resolution ancient DNA from the deeper pre-Iron Age period, genetic material old enough to actually trace the original mixing events, the earliest phases of isolation, and the point at which steppe ancestry that reshaped the rest of Iberia largely stopped at the Basque border. Those samples are still being recovered and analyzed, and when the results come back, they'll almost certainly revise this story again. Because that's what keeps happening every time the technology catches up a little further with a population that has spent 3,000 years quietly refusing to become part of everyone else's history.